My topic is about the difference between threads and processors, so which comes in the Linux programming. Now let us discuss about a few other topics. So first of all, what is in process? Here, the process is an active program that is under execution. It is more than the program code, as it is include the program counter, process stack, registers, program code, etc. Compared to this, the program code is only text section, which is lightweight. As a thread is a lightweight process that can be managed independently by a scheduler. It improves the application performance using parallelism. A thread shares information like a data segment, code segment, files, etc. with its p threads, while it contains its own registers, stack counter, etc. So basically, communication between the process requires more time than the between threads. So process requires more resources than threads. Threads generally needs less resources than processes. So basically, thread is a lightweight process that can be managed independently by scheduler. It improves the application of performance using parallelism. A thread shares information like data segment, code segment, files, etc. with its p threads, where it contains its own register, stack counter, etc. Whereas a process is an active program that is under execution. It is more than program code, and includes the program counter, process stack, registers, program code, etc. What is a process? Processes are basically the program that are dispatched from the ready state and scheduled in the CPU for execution. PCB process control block holds the concept of processor. A process can create other processes which are known as a child processor. This process takes more time to terminate, and it is isolated, means it does not share the memory with any other processes. The processes can have the following states: new, ready, running, waiting, terminated, and suspended. Here, these are the 5 steps comes under the processes. First one, new, ready, running, waiting, terminated, and suspended. Where is thread? Thread is a segment of the process, which means a process can have the multiple threads, and these multiple threads are contained within the process. A thread has a 3 states: running, ready, and blocked. Just only 3 states, whereas in process it has 5 states. Whereas in running and ready, blocked, the threads takes less time to terminate as compared to the process. But unlike the process, threads do not isolate. See, as we can see that process having the 5 states and threads having the 3 states. Now thread is a segment of the process, means which having the process can have the multiple threads, but these multiple threads are contained within the process, so that the threads are 3 states only. So we can see the diagram showing the process which contain the code, data, files, register, and stacks. Which having thread, we can see the process of the format, the process and thread. Now, what is a process? Process is an execution of a program that allows you to perform the appropriate actions specified in a program. It can be defined as an execution unit, whereas program runs. The OS helps you create, schedule, and terminate the process which is used by CPU. The other processes created by the main process are called child's process. Process operations can be easily controlled with the help of PCB, and PCB process control block. You can consider it as a brain of the processor, which contains all the crucial information related to the processing, like the process ID, priority state, and contents of CPU register, etc. That is an execution unit that is a part of a processor. A process can have multiple threads, so that all the executing at the same time. It is a unit of executing in execution in concurrent programming. So basically, a thread is a lightweight, can be managed independently by scheduler. It is helps to use it to improve the application performance using parallelism. Now, here multiple threads share information like a data, code, files, etc. So we can implement threads in three different ways. So which is kernel level threads and user level threads and hybrid threads. So basically, a thread is a lightweight Bluetooth that can be managed independently as a scheduler. So which can help improve all the application performance using parallelism. Also, a thread is a unique integration execution unit that is a part of processor. So process can have multiple threads, so all executing at the same time. So it is a unit of execution concurrent programming. Now, properties of a process. Here the important properties of a processor. See, creation of each processor requires separate system calls for each processor. It is an isolated execution entity. It does not share data and information. So process use the IPC inter-process communication mechanism for communication that significantly increase the number of system calls. So creation of each process requires separate system calls. The process management takes more system calls, and process has a stack heap memory with memory and data map. Also, process use the IPC inter-process communication mechanism for communication that significantly increases number of system calls. It is an isolated execution entity or does not share the data and information, as we can see that. This is a main important processor. Basically, process having the more stick and heap memory with a memory in the data map, which is using different form of the different communication process. Whereas using the inter-process communication IPC mechanism for the communication that majorly increase the number of system calls. Also, process management takes more system calls. Properties of a thread. Here, a single system call can create more than one thread. Threads share data information, and threads share instruction, global and heap regions. And also, however, it is a register and stack. Basically, thread management consumes very few or no system calls because of the communication between the threads that can be achieved using shared memory. Basically, thread is a unique execution unit that is a part of processor. As we can see, the processor can have the multiple threads, but is all executing at the same time. So it is unit of execution in concurrent programming. As basically, so that here single system call can create more than one thread, and also basically in threads sharing the data information is more easy due to the slightly thread part, so that they shares more types of instruction which are global and heap regions also, basically which comes in a larger area, and it has consumes very few or no system calls because of the communication between the threads that can be achieved using the shared memory. Thank you.